Hello, today I will be going through question 1 of the BMO1 paper from 1996. The question is as follows. N is a 4-digit number that does not end in 0, and Rn is a 4-digit number obtained by reversing the digits of n. For example, if the number n was 3275, Rn would be 5723, and the question states that we have to find all such integers n for which Rn is 4 times by n plus 3. So the first thing that I'm going to do is I'm going to explain my method, which was surprisingly very wrong. Then I'll show the first method, the first discussion from the book of the problem, and then I'll show the solution from the book that should give 10 marks, because in the BMO it's all about how you prove it and not as much about the solution. So the first thing that I did when I saw this was a question about rearranging the digits of a number was that I wrote n as 4 digits. That would be A, B, C, and D. And I wrote Rn as the reverse of this. So D, B, D, C, B, and A. Because it says it does not end in 0, and it's a 4-digit number, we know that D can't be 0 and A can't be 0. So that rules out 2 of the 9 digits that each of these could be, because these are each 1 digit. So A could be anything between 1 and 9, D could be anything between 1 and 9, and B and C can be anything between 0 and 9. The next thing that I did was I also tried to write n out as an actual number that I could calculate with. So if A, B, C, if the number is written A, B, C, D in digits, now there are 2 paths to go down from this initial setup. One was the smart way in the book, and the other one was the one that the book did not like, which I'll explain more about later, but I took the wrong path. So it says it's a 4-digit number, so we know that D has to be smaller than 9, and if you write Rn is equal to 4n plus 3, then there are certain letters that, so A wouldn't be able to be bigger than 1, because 1 times by 4 plus 3 is obviously 7, which works. So D would be 7. But if instead of 1 you had 2 times by 4 plus 3 would be equal to 11, and if it's a 4-digit number, D has to be smaller than or equal to 9. So we already know that A has to be 1. And I'm thinking about this like a sizing argument, but the book crushed my hopes and dreams. It didn't like it very much. And I tried to use this all the way through in my first method, but it didn't work very well, because while you can do this for A and partly for D, you couldn't really do it for the middle two, and so the working out kind of fell apart. But it does give you A in a nice fast way, which I give it credit for, because the book also gives a nice way to get A using parity and modulus, which I'll go into in a second, but I think this is like a more logical way to get A. All we have to do is represent n as the number A, B, C, D again, and then if we have Rn, it's just the reverse of that. We have Rn is equal to DCBA, which is equal to each of these multiplied by that. So it'd be A, B, C, D, the bracket of the 4 multiplied by 3. And with A, it works best because you don't have to worry about a number that's larger than the units, than just the ones, because if you were to multiply D by 4 and then add 3, we can't compare this to the A, because part of it, if it was, let's say, 2, you'd have 2 times by 4 get 8, 8 plus 3 and you get 11, but the A would only show 1 because the extra 1's been carried over to the B, and that complicates things. And that was really where this method fell apart. And that's where the other method that I should have chosen initially, that had represented n as 1000A, 100C, 100B, my bad, 10C, and D. You could multiply all of these by 4, giving you 4D, 40C, 400B, and 4000A plus 3 is equal to just Rn, which is this number, DCBA, which can be represented as 1000D plus, 100C plus 10B plus A. My handwriting is really bad, I'm sorry. And because we already know what A is, I will show the better proof for A, but because we already know what A is 1, we can cancel out A. So you have 4000 plus 400B plus 40C plus 4D plus 3 is equal to 1000D plus 100C plus 10B plus 1. And it's at this point that you have to start using modulus. You have to start using modulus here, because there's no other real way of removing the B and the C terms. Because you want to have one letter out of this. You only have one equation, but you have 3 unknowns. And so congruences with modulus is a really good way of doing that. But I think it would be better to show that after I've explained A. So I'm going to explain A first. So the superior method for showing that A is odd in the book simply uses parity, which is basically modulus base 2. Modulus is where you remove all of the parts of the number. Like you subtract the number again and again until you can't anymore. So let's say you had 5. This is a very bad way of explaining, but if you had 5 mod, I wrote that backwards, 2, subtract 2 as many times as you can, take 2 out, taking 4 out, you have 1 left. So it's kind of the remainder. That's the better way of putting it, it's the remainder. And parity is looking at the congruence, which is basically, are numbers the same? Are they congruent with the same modulus? So 5 mod 2 is the same as 7 mod 2, because they're congruent, because they're both odd, and if they're odd, then the modulus base 2 is going to be 1. If it was 6, it'd be 6 mod 2 is equal to 0, and they wouldn't be congruent. So they just use plain parity, but in the book they say parity and modulus go hand in hand in this example. So what they do here is they use the definition of n, that n is 1000A plus 100B plus 10C plus D, and then they just say since Rn is odd, it follows that A is odd. And that confused me, because I don't see anywhere in the question that it says Rn is odd. You have to look closely. It shows Rn is equal to 4n plus 3. This bit is an even number. An even number plus an odd number is an odd number. It took me a while to see that, because I don't explain that. And then, well, how do you know that A is odd? It doesn't say that either. Well, Rn is equal to 1000D plus 100C plus 10B plus A. All of this stuff here is even, but we know this thing here is odd. And the only way to turn this even number into an odd number is to add on an odd number. And so through this, because if you add an even number, you're going to get an even number. So you have to add an odd number to this even to get another odd. And through this, you've shown that A is odd. And then it says, because 4n plus 3 can only have 4 digits. So 1, 2, 3, 4. That means that A has to be smaller than 3. So this is like a sizing thing that I was doing earlier, but they just want to show it differently. And if A is smaller than 3, A is 1, 2, or 3. Actually, not 3 because it's smaller than 3. And because it has to be odd, there's only one odd number it can be, and that's 1. So this just shows A is equal to 1 in a different way. Apparently better. We're going to go back to solving for D using the modulus trick. So, because we know where A is, we can say 1000D plus 100C plus 10B plus 1 for the A is equal to 4000 plus 400B plus 40C plus D. And then you can rearrange this and I mean, you don't have to rearrange it at this stage, but it looks nice when you do. You just do mod base 5 to both sides. This 1000 term gets cancelled, so does the C, so does the B, because anything multiplied by 10 is going to have a 5 as part of it. It's going to have a remainder of 0 when divided by 5. But then you get 1 mod 5. It should have been 4D. 4000 gets deleted, so does the 400 and the 40. But because this is just 4D, it doesn't get deleted. So you get 4D mod base 5. And now you have to find a multiple of 4 that ends in 1, because the mod 5 would remove a power of, would remove a multiple of 5 from it. So if this was, say, 28, I think I did something wrong somewhere. I should have done plus 3 here. And then when I rearranged it, this should have been a minus 2. And yes, you can put minuses in modulus. It just, you have to think about it a bit different. Mod 5. Yeah, so now it has to be a multiple of 5 plus 3. That's equal to 4D, which is that's all that these things do. They just remove a multiple of 5 from both. And because we have a range of values for D, they shouldn't be too hard. I don't like thinking about it like this. I don't like showing it as this. So I could just rearrange it, as in show it with algebra. Or I can list it all out. And so if we list out numbers that are multiples of 5 plus 3, you have 3, you have 8, you have 13, you have 18, you have 23, you have 28. And then you can go further, because this represents D. The multiple of 4 represents D. And so you have 8 is a multiple of 4, and you have 28. You could go further above this, you could go 33, and then you could go after that 38. But these are the only two multiples of 4 where D is smaller than 9, because this is 2 times by D and this is 7 times by D. because both of these, if you do mod 5 to them, you get 3 out because they have a remainder 3 divided by 5. And you can get these from 4 times by d. So the possible values of d right now are 2 and 7. And I just worked them out by listing it out. I think that is the nicest way of thinking about it. You can try to do algebra on the mod base 5 bit, but that's more tricky. So what you would do is you would divide the 4 across, and you'd get d mod base 5. That's horrible writing. Somehow this becomes 2 mod base 5. This was in the explanation part of the book, so the book that I'm using, A Mathematical Olympiad Primer by Geoff Smith, very good book. It has a section where it explains all the content per se that you might need for BMO1, and then a section with questions, and then a section with solutions. And in the section for modulus, it explains division, but it went over my head no matter how much I tried to think about it. So this works with the algebra, so that becomes that becomes that. But listing it makes more sense to me. This is why I listed it. Okay, so far we know that if n is shown as a, b, c, d, a is 1, and d is equal to 2 or 7. Now we need to figure out which one of these two it is before we can move on to solving for b and c. So the first thing that we do is we equate Rn and 4n plus 3 the way the equations were before we use mod 5 on them. So that would be 1000 d plus 100 c plus 10b plus a, which is 1, is equal to as an a, which is just 1 actually, plus 400c plus 40b plus d plus 3. So now if you rearrange this, I'll skip the rearranging, but you can do it yourself. You get 166d plus 10c is equal to 65b plus 667. So if you look at what d could be, it could be 2 or 7. But if you sub in 2 here, then and you sub in 9 here. So let's say you make b as big as possible. You put in 9 there. 65 times by 9 plus 667. Oh wait, no. You make b as small as possible. So you make b 0. 667. There's no possible way that this side here would be equal to 667. Even if you make d as big as even if you make c as big as possible. If you make c 9, you have 90 plus 2 times by 166. So that'd be 332, I think. Plus 90 is still 422. So it's still smaller than this. So d can't be 2 because that makes this side here too small. As a result of this, we know that d is equal to 7. And we can sub d in. Which gives us 1162 plus 10c plus 65b, or is equal to 65b plus 667. And this simplifies to 99 plus 2c is equal to 13b. So far, you could have done these steps without exactly knowing what you're trying to do, because with these Olympiad questions, it's very hard to see the whole path before you've solved it. And so up until now, you can understand the direction you're going in. You don't understand it. But for the next part, it's like you almost already need to know the next step. So you know what 2c is. You know 2c has to be between 0 and 18, because c is between 9 and 0, inclusive that is. And so you can sub in 2c is equal to 13b minus 99. So getting it to this form was very important. So to just go back over what we just did, we found d by putting in 2 and then showing that the two sides of the equations could not be equivalent because 2 is too small a value for d, that is, which is a very hard thing to spot without doing the calculations first. And then now that you have a and d and you put them in, you're now finding the range of values that b could have based on the range of values that you know c has. So you know 2c, like I said, 0 and 18, and we sub b in, and you get 13b is between 13b minus 99 is between 0 and 18. So this lets you know that b is between 13b is between 99 and 117, which means that b is between, and you have to consider that this is a non-calculator exam, so doing it this way may have been slightly misadvised, because in the book it does C, but I'm doing it for B. But regardless, you can find out what it is. The easiest way to do this would be to find multiples of 13. So if you look at 8 times by 13, you get 104, which fits in this range. And then if you look at 13 times by 9, you get 117, which is on the boundary. However, there is a fact that we may have missed beforehand, and that fact is that b is also odd. We can conclude this because you have 2c plus 99, so an even plus an odd, and then the result here is 13b. 13 is odd, but that changes nothing, because if b is even, then this whole side becomes even, but this whole side is odd, so we know that b must not be even, meaning that all b can be is odd, so b has to be odd. Another thing you can miss very easily, that I just missed now, but b has to be odd, meaning that b cannot be 8, b must be 9, which means that it does fall on the boundary, and b is equal to 9. And if you sub this back into this equation, 2c plus 99 is equal to 13b, where b is 9, you do get c is also equal to 9. And that's how you get the whole number is 1997. So you got a is 1, b and c is 9, and d is 7, which is a reference to the year, because the year this was sat in was 1997. Now, I think this is a perfect example of how Olympiad problems are very hard to see all the way through at the start, because there's so many twists and turns in the solution. And it does require a good level of knowledge about modulus to understand what you're doing. because otherwise you have to resort to listing numbers and then just dividing them and seeing what has a certain remainder. And I could have guessed because Senior Math Challenge and Olympiad challenges often have its year in as an answer to a question. You could have just put it in and checked. But even if you've written that answer, you would have gotten no marks. Not even 1 mark for that answer, because they want to see the working out. And so, as far as I got by myself, which was up to basically B and C, I would have probably got barely any marks, maybe 3 marks max. And so you have to, like, as a strategy, you could do part of the question and then move on and then come back to it and look at it again and then try the next part. And the important thing is you're working out. So you have to make sure it's nicely laid out. I have a debuff because of my handwriting.